All right, so if everybody's back in their seat, and let's see, I know we have at least a couple of people online. So hi, Mom, Dad. I sent my parents the link, so we should have at least 2 people joining our live streaming event, maybe more. So I'm Jeremy Davis. I'm a principal solution architect at Red Hat. Prior to joining Red Hat 7 years or so ago, 8 years ago, I was all heads down development. So I used to code a lot during the week. Now I get to code some during the week. And we're going to talk about reactive programming and reactive systems, right? First things first is why bother talking about reactive systems. So yeah, if you guys can hear, if anybody can hear me, also, if you have questions, shout out questions. You know, happy for you guys to interrupt. Make sure that you can also save questions to the end if you want, but be sure to also just shout anything out. So why are we talking about reactive programming? So to start here, even though reactive is kind of a new thing, right? It's hottest. And who's heard of reactive programming or done any reactive programming? Handful of people. All right, so I'm going to go back a long time ago, so about almost 50 years ago, to talk about why this makes any difference. And this guy is Jacob Nielsen. So in the early days of the internet, which is when I started my career, got my first job, coding JavaScript. Not my first technical actual job, right? I mean, I worked in a convenience store and did landscaping and stuff. But got my first job when the internet was coming around, right? And Jacob Nielsen was a web guru, and he had this incredibly boring text-driven site, which was kind of funny for a web guru. But his whole thing was about responsiveness and speed. He's a user experience guy, and he had started his career on green screen systems, right? So he's doing user experience for green screen systems, which might sound a little funny to us today. But he has these 3 numbers, and he went from green screen systems to fat client, desktop applications, to the web, and now to mobile, mobile and handheld. And he has these 3 numbers, and 0.1 seconds is the amount of time that something can take for a user to feel like it's being responsive, like they're getting immediate feedback. I mean, you move your mouse, and your mouse moves, right? 1 second is the amount of time before users begin to start to wonder about responsiveness and begin to lose their train of thought. And if something takes a second, then you need to provide the user some mechanism of feedback. So for instance, you're spinning beach ball. I have a Mac, right? You get the spinning beach ball when something's taking a while. That's giving you feedback to say your computer's not dead. Or when I click on IntelliJ to fire up IntelliJ, right? It's not like I start coding instantly, but I do get a splash screen, and then I get a little progress bar, right? We get little timers on our websites. So if something takes more than a second, users need to see some kind of progress. 10 seconds, users begin to lose interest and change and context switch, right? So if it takes 10 seconds and nothing happens, you begin to do context switching. And you start thinking about something else, like did I respond to that email? Is Manchester United going to actually finish that Sanchez trade, right? Those kind of things will start going through your head. What's interesting about this is over these 46 years that he's been doing user experience, these numbers haven't changed. So we've gone from green screens to fat client desktop applications to web applications, and Apple even recently got dinged for this on the iPhone, right? So the iPhones are slowing down and users get angry. So there's something innately human about this notion of responsiveness. And the other reason this matters is innovation. So FedEx, I recently read a book on innovation and technological innovation, and FedEx was singled out for their sense-aware system, which is the track my package piece. When you go to their website or you're on their mobile device, right? You can track your package. When we think about technological innovation, we often think about kind of the big revolutionary things like the desktop, the smartphone, right? The web. But in the enterprise, technical innovation often means interacting with customers, right? In new ways. Right? How do we get in touch with our customers? How do we get feedback to our customers? And typically, we're doing that electronically, right? In fact, the reason that FedEx created their sense-aware system was because they found out that most of the calls that came into their call center were people calling in to say, where's my package? Right? And so they were able to get faster feedback to their users by putting this on their website. Right? And now everybody has a track their package, right? So as enterprise developers, we're increasingly being asked to provide value by interacting with our customers. And customers have attention spans of 0.1 second to feel like they're being responded to or that you're interacting with them, and 1 second before they start to lose interest. So reactive programming is all about being responsive, and that's why this matters. there's also some tools, right? And in fact, this ends the sort of business value, high-level part of the presentation. We'll talk technology for the rest of this talk. There's tools. We'll look at 3 sort of prominent reactive, well, actually we'll look at 4. One's missing from my slide. So we're going to look at Vertex is a Red Hat, or Eclipse Vertex is a Red Hat product. It's part of the Red Hat runtime shootout that you'll see just after my talk. We'll also look at Akka, at Spring Reactor, and at RX Java. So there's sort of 2 paradigms. There's reactive systems, and then there's the reactive programming. And obviously, they are interrelated. You build reactive systems by doing reactive programming, and you do some reactive programming inside of reactive systems. And we'll look at both of these. So this top piece of code here, we'll look at in a little more detail, is reactive programming using RX Java. Has anybody used RX Java or any of the other kind of RX libraries? Okay. And then the bottom here is from the the bottom here is from the Reactive Manifesto. Right, we had an Agile Manifesto, now we have a Reactive Manifesto. This was started by the Lightbend guys. There's a lot of text on this website, so there's a lot to read. You can sign the manifesto, so I'm a signatory to this manifesto. You can find me if you search. But you can join the 21,000 other people who believe that applications should be built this way. Reactive programming has largely gained steam inside of the Android community. So if you've done any Android programming, you'll see a lot of people leveraging RX Java, right? There was a great blog post or article written by the guy that invented RX, who was at Microsoft at the time, a guy named Eric Meyer. And the title of his blog post was, Your Mouse is the New Database. Right? And he talks about reactive is all about responding to events, and obviously in a user-driven environment, right, you have a lot of events. But we're not talking about, it's not Red Hat Android Day, right? It's Red Hat Microservices Day. So we're going to mostly talk about reactive systems, not reactive programming. So reactive programming and reactive systems have a lot of overlap or things in common. One of the things is they both address the realities of the world that we're working in today. In reactive programming, it's all about events, and it's all about being event-driven. It's not about executing things in an order, it's about responding to something that happens. So in reactive systems, they're message-driven. Instead of controlling the flow of an application, traditional code, you respond to messages, right? So you get a message in, and you take some action on the message, and you send a message out. Reactive programming embraces the realities of data, right? That we may have unlimited amounts of data, right? In an IoT space, like sensors, we're going to have unlimited streams of data. Streams have made it into Java, right? Reactive systems embrace the realities of the network, meaning the network's fallible and it's not always going to be there. And when you combine those 2 things, it gives you a lot of uncertainty. Like you can ask for data, but that doesn't necessarily mean that you're going to get it back. Or maybe you only get part of it back. And reactive just assumes that there's going to be times when you don't get it all back. And it builds in at the ground level ways to deal with that and to stay responsive to your end users. So the Reactive Manifesto and Reactive Systems, the manifesto boils down to this statement that there are 4 things that systems should be. When we talk about large distributed systems, these are the things they should be, right? First and foremost, they should be responsive, right? They should be responsive because users don't have long attention spans, right? And we need to make sure that we're always staying in contact with our users and giving people a response back. They should be resilient, right? So it means that they should, you should be able to replicate. They should be isolated, right? The things should be contained within themselves, or failure should be contained. They should be elastic, meaning they can scale up or down, right? In internet speed, today we have, what, 2.7 billion users of Facebook? Things can explode overnight. You put a track my package feature on your website, you never know how many times people are going to click that, right? Or how many times they're going to ask for that information. I mean, who else totally checks their Amazon app all the time to see if your book is going to be there, right? And then message-driven, and this is kind of at the heart of this notion, is that these applications should be message-driven, right? And they should be self-contained. So the reason this matters in a microservices world, as opposed to just a traditional large system, I think goes back to the very first microservices article, right? When Martin Fowler and James Lewis coined this on Martin Fowler's Bleaky, they talked about what microservices are, and the things they mention is, right, they are individual, independent processes, right? You can deploy them independently. They don't require a whole bunch of other things to be deployed at the same time. They have their own data. They're independently manageable, right? They often deal with HTTP. They're often API driven. So if you think about being independent, well, if an application isn't going to rely on something else, if it's in charge of its own ability to stay alive, you're looking at resiliency. You're looking at being elastic, right? You're looking at being responsive. Because if some other part of the network fails, you don't want to come down as well. And toolkits, libraries, and frameworks, right? So the fun part. There's lots of new toolkits. There's more than this. These are 4 very prominent ones, and we'll look at these in order here. So we'll start with programming. So ReactiveX. And a couple people have said they've used ReactiveX. ReactiveX started, or Reactive started at Microsoft. It was originally done in .NET. It's ported RxJS as a JavaScript library. RxJava is what we'll be looking at, but there's a lot of different languages. And if you come to their website, you can even see that we have Java, JavaScript, .NET, Scala, Clojure, Swift, and a whole bunch of others too, right? So pretty much any language you want to use, you can use these extensions. Some of the syntax varies a little bit, so they're not a complete switch from one to the other, but they're all basically the same thing. They all deal with the same sort of ideas. If you become comfortable with one, then it is easier to move to one of the other ones. Where they're different from traditional programming, if you think about the way that you write, you do traditional programming, right? You call a method, you get something back from that method, right? You store that in a variable, and then you do something with it. In Reactive, it's a little bit different, right? So first, you create a method that does something useful, right, with the data you're going to get back. And then you define an asynchronous call, and that's an observable. Observable is the key word when you're talking about RxJava. Then you attach an observer or a subscriber. You subscribe to that observable, and then you do some other stuff until you get your answer back. And observables are lazy. They don't do anything until they actually get some data back. This is what an observable looks like. If you haven't used this before, it probably looks a little strange, right? I know it was very hard for me to wrap my head around this. I've done a bunch of reading. I highly recommend the book RX Programming by Ben Christensen. He's a guy that came from Netflix. 2 guys at Netflix looked at the way that they called their own APIs and implemented RxJava. He's one of the guys that wrote RxJava. It has a couple of great talks. And I have links to all of this stuff at the end of the presentation. So I'll have the slides available like on SlideShare, and maybe we can email them out. But there's a lot, watching his videos really helped me understand what this kind of stuff does. And we'll run through some of this. What this observable is doing, this is very basic. It's just sorting numbers, right? Let's jump over to IntelliJ here and see how many possible things I can have, how many IntelliJ windows I can have open. So if we look at this observable, we have an observable. And what it's going to do is we're calling this method range, which is a method on the observable, and we're just going to count to 100. And then we're going to sort. We're going to call this method group by on these numbers, 1 through 100, and we're going to use a modulo, sort them into even and odd numbers, right? And we're going to call this funny-looking thing called flat map, which is also incredibly useful and incredibly common inside of RxJava. And then for each result we get back, we're just going to call system out print line, right? So what you get when you run this is a blank screen. What you get when you run this here is sorted numbers. Now this might seem a little abstract, right? I mean, we're just sorting numbers. But when you're dealing with streams of data, the ability to very easily write some code that's going to take things in, do some transformation on them, and then spit out sorted values, multiple sorted values, is pretty powerful. Now the notion of if you're familiar with the observer pattern, right, we all remember the Gang of Four book. So observable is very similar to the observer pattern, like that you had in the Goff book. But there's a couple other things that have been added to it. And the really sort of key important pieces that have been added are on completed and on error. Like I said, I mentioned that observables are lazy. They're not going to do anything until you subscribe to it and tell it to start giving you values. But it treats errors, one, as a first-class citizen. We know that sometimes we're not going to get back all of the data that we want. And so what we're going to do is we're going to send a message to our subscriber that says we had an error, or we're going to write some code to handle that. And then on completed, we're going to exit. We're going to say we're done, right? Because we may not be done. Like sometimes we get lots and lots of data. Another key piece are operators, or marbles. And that's what we saw inside of Observer here when we looked at, group by and flat map. And on the RX site, they do a really nice job of using these marbles and using these marbles to explain what's happening. So we get this data in, and if we apply an operator called flip, we flip diamonds around, right? So we're not doing diamonds, right? But your data changes when you apply these operators. And you can come walk through, all these operators are listed here on the site, and you can chain these together, and they are all listed, and you can look at these diagrams to see what they're doing. And when you first start playing, at least if you're like me, and like I think most people that start this, when you first start playing with RX Java, you're going to spend a lot of time looking at these marbles, right? Because it makes life a lot easier. So we look group by, right? We have an observable, we have a range, we're going to count to 100, and then we have a group by. So we can come over here and we can say group by. And group by shows me what it's going to do. So it says I'm going to get this data in, and I want all the circles, or all the odd numbers, in one group, and all my triangles or even numbers in the event in what we just ran in the other. So we're going to send out, we're going to group these by some criteria, right, that we write. And then we're taking group by, and we're passing it to flat map. So we can look at flat map. And we can see what flat map's doing. And flat map is taking observables and turning them into a map of new observables. But you can walk through what you're doing. You get really, really nice documentation. And you even get examples of the different, so there's RX Java 1 and RX Java 2, JS. You can get, Kotlin, whatever language you're using. You can see these examples. But you can spend, if you begin doing this programming, get very familiar with the marbles. There's also a pure JavaScript version called rxmarbles.com or .com. It does the same thing, and this is interactive, so it lets you play with this. We can see, what's going to happen. We're getting these two streams in. We can see what would happen if we move this one here, right? Which, that's pretty obvious, but you can come play around with these. Now, I mentioned that the guys at Netflix originally wrote this library, and when I was listening to his talk, he explained the way that this particular UI works, right? So when you log into Netflix, Netflix code says, give me 30 movies to recommend for this user, right? But maybe not 30 movies, maybe 30 movies don't come back, maybe 10 movies come back. So what do you do if 10 movies come back? Well, maybe you've got some default things that you suggest for somebody, right? So maybe we're just going to send some default stuff we'll send in there. Or maybe we use something from another family member so that, so top picks for dad, I like to think that I actually encountered an error and that the RX Java code in Netflix wasn't able to pull back all the recommendations for dad, and so that it defaulted to the lab rats and a series of unfortunate events, because those are not actually top picks for dad, right? It's also possible that my kids were watching under my login, right? But and this was the correct recommendation for dad. But it also might be because the observables only got back this top row, and we used some cache data or another family member's data. We handled that error, right? But this gives you a good example of how we pull things together. So maybe we want to get back a list of books and recommendations, and we're writing a UI. We have two different UIs we have to call to get those recommendations. In a blocking world, and this is how Netflix began this journey and why they created this implementation, was they have lots of different APIs they would call, right, to build this UI. We would say, give me these movies, give me the things that are available under this person's account, right? Give me other recommendations. Maybe have things that are still in progress, right? So you get this little streaming bar, if you watched a couple of minutes of this. This could be 10 or 15 services. I think he actually said there was something like 30 services at some point that were called. Well, in a traditional blocking code, right, like if we're inside of a Java servlet, we say, oh, go get that, and I'll get that back. Okay, wait, now go get this other thing, and get that back. Give me this other thing, too. Now I'll do that. That starts to take a while, right? And users start to notice when things take a while, right? So in an observable, in a reactive world, what we do is we say, go get these 30 things. Do some other stuff. Okay, they're coming back in. I've got them. Got it. Oh, error on this one? That's okay. Go. So seeing it in the real world made a lot of sense. And seeing this with actual examples made a lot of sense. All right, so to sum this up, so RX Java, it's all about the observables. There are some other objects. There's something called a single, but it's really about observables and operators. There is a big learning curve to this. In fact, one of the things the Netflix guys said, that even developers, you have 10 or 15 years of experience, it's still kind of tough to wrap your head around this. But once you do get your head around it, it's pretty efficient, and it becomes pretty natural. And use the marbles while you're getting your head around it. There's also one other thing they mentioned, and this is going to feed into the reactive systems, right? So I wanted to call this out. And they said that there's a lot of different ways. They use different languages. They use a number of different languages that execute on the JVM. They use Groovy. They use Java. They use JavaScript. But one rule they have, and they said one of the key rules was don't mutate state outside of the function. And we'll get into that when we look at our reactive systems, too. Now, there's standards are afoot here. Reactive streams is part of Java 9, right? So we've got reactive streams. This class flow and flowable are inside of Java now. It's not really for end users. So reactive streams is really an interoperability layer so that the people who are writing these kind of frameworks or toolkits can interact with one another. But this is getting baked into the language. So the notion of reactive programming is something the industry is really beginning to coalesce around. That's one reason there's so many different languages that are part of RX, right, or part of Reactive X. Reactive streams, this is on GitHub. The whole spec is on GitHub. We're one of the supporters. Pivotal's one of the supporters, the guys that do Spring. Netflix is part of that, and then Lightbend. Lightbend are the guys that make Akka, which is what we're going to talk about next. So has anybody used Akka before? One Akka user? All right, so I'll say I first saw Akka at an event similar to this, not put on by Red Hat, but an event similar to this. And my impression, this guy gave this really in-depth talk on Akka for a couple of hours. And my immediate impression was, that looks really complicated. I never want to use that. But as I began digging into reactive programming over the past year or so, I began getting my hands dirty with Akka, and my impression now is Akka is pretty cool technology, and I could absolutely see myself writing an application in this and really enjoying doing it. There's a lot of really clever things that went in there. So the takeaway from that is, one, we can talk about technology all we want, but at the end of the day, you got to roll your sleeves up, get your hands on keyboards, play with it, and you'll decide the things that you like best, and the things that you enjoy using. The other takeaway is that even if a speaker makes your head spin or thinks this stuff is too complicated, they might be wrong. So at the end of this talk, if you think that reactive programming is too complicated, go home and try some anyway, right? Maybe you'll change your mind. But Akka is all about actors, right? So every class in Akka is an actor, and they all communicate through messages. So Akka actors send a message. They each have a mailbox, right? They send messages, and then they have children. So it's a parent-child relationship with one sort of actor system at the top, and it controls everything below it. And these are by the guys, I should have mentioned, the Lightbend is the company behind this, and these are the guys that wrote the Reactive Manifesto. So this is end-to-end reactive from the ground up. What it looks like, let's get rid of some of my IntelliJ windows here. So what an Akka, this is an example of an Akka test case. And they've got nice test stuff built in, right? So they got a test kit that's built in. You can run this right inside a JUnit. You get a reference to this actor. And then we do this call here, device actor tell, and that's when we're sending our message. The messages are a class that's on the actor itself. So the way they recommend building this out is we go to our device. Let's just go to our device manager. Our device manager has a class here, request track device. And it's got group ID, sort of is internal business logic around this little example app. And this one doesn't have a message ID. So typically you put a message ID in here. Part of that comes from the messages, remember, don't mutate state outside of the function. So you're going to send a message to an actor and request that it do something. You're also going to send it an ID of a request ID. It's going to send you back a message telling you what happened, like I succeeded or I failed, and it's going to send you your request ID. That way, we think about our systems going back being resilient, right? If it goes down and you don't get a response back, and you send another one, and you get that request 2 first, it's up to you to deal with that, right? So you always deal with your own, each piece, right? Each actor or each piece of code is responsible for its own life cycle, and responsible for handling things and staying alive and dealing with any kind of failures. Some of this looks very like traditional programming, right? Typical methods. And then we have something called create receive. And we just match here. We match on events, right? So we match, this one's kind of, this one only really has one request. Let's look at a better match example, right? So we can match on multiple different classes, right? And the class tells us, what it is we're supposed to do, right? So we get a particular class in, like, well, terminate is an event. Like if one of my children terminate and fall, we call this method. Get this class, we perform this method call. Another thing that Akka does, the way all this works, is it creates URLs or URIs for all of the actors in the system. And you don't call that directly. And that goes back to part of the notion of being elastic, right? We need to be able to scale up and scale down. So the Akka system itself can tell you, we're handling a lot of processing. Let's spin some more actors up, right? Some more actors to handle this. And if we look inside of our code, where's our test? Let's run this test. Let's debug this test. Step over here. So now we have a reference to our actor. And you notice here, there's our URL, right? So we have a URL that points to this actor. So the actors can find each other, or they can find each other's mailboxes, right? And they can send this message over to the mailbox. How am I doing on time? I'm taking up a lot of time. So to sum up Akka, it's reactive from the ground up. It uses message passing. It uses the actor model, right, which is a model that makes each actor independent. Each actor is scalable. It's responsible for handling its own errors. It's responsible for doing its own work. And there's some other kits, like there's an Akka Web and an Akka Streams to help you deal with some streaming data. Because that wasn't really reactive programming, right? We didn't really see into those kind of reactive programming. All right, so next toolkit, Vertex, right? So Vertex, you're going to see some really in-depth Vertex in the shootout coming up. But we'll give a quick look at Vertex right now. So Vertex was a JBoss product originally, started by the guy that originally wrote HornetQ, which is our super fast JMS messaging system. So as you might have guessed, an event loop is part of this, right? A non-blocking event loop. So the guy, Tim Fox, is the guy that started the project. Right around the time that Node.js came out, Node.js came out and was very famous for having a single-threaded event loop, right? Everything comes in on one thread. And this was very similar to what was going on inside of HornetQ, the messaging engine. And so he said, you know what? I'm going to create a toolkit for building complete applications this way. So everything works on an event loop. And the cardinal rule of Vertex is do not block the event loop, right? Because you want to stay responsive, right? It goes back to, we talk about a system being responsive. Don't block the event loop. Always make sure that you can return data. Everything gets done, usually, in a Vertex project inside of verticals. And verticals are really small classes. You can see, let's move this one down too. I have a lot of windows of IntelliJ open. I'm wondering if I can possibly run out of memory in the middle of a presentation. So we want to see, this is a vertical. Verticals can be pretty small. And that's a web server, right? Start a server. And this actually, we're using a toObservable method in here. This is another thing about Vertex. RX style programming is built in. You don't have to use it, right? So you can write completely reactive applications without using RX, but RX is built in as well. So if you want to write really reactive code, it makes it very easy to do inside of here. An event bus is also key to Vertex. This also gets back to being message driven, right? What do you send on an event bus? You send messages. The recommended format and the typical format is you use JSON to send messages. JSON is really nice because we're always dealing with essentially a string payload, right? It also means that it's language agnostic. Everybody has a toolkit for JSON. In fact, I'll fire up an application here. Your browser can talk directly to the Vertex event bus. Let's get this running here. So I'll fire up some Vertex microservices here. It's also pretty small, so you can fire up 5 instances pretty quickly. But this also means that you can be responsive, right? So a request, like if we're building a web API, right, an HTTP request, a request can come in, we can fire a message over to the event bus, and then that work can happen on the event bus, and then send the result back, right? And we'll pick that up or execute a handler on that code when it comes back, which means we can scale out tremendously, right? And we can perform work really, really quickly. So one example application, the example application that I just fired up here, a lot of really good resources too. This is a tutorial called From Zero to Micro Hero about building microservices. It's a little trader application, and inside of here you'll see a number of things that are really typical, right? We're going to interact with a database. We have a web UI dashboard, and then we've got a quote generator that's sort of simulating stock market. And then a portfolio that stores data about our customers. And then we have some traders that execute some sort of crazy logic to buy and sell stocks in this thing here. So let's fire this up. And this is also, we're talking directly over WebSockets, right? So we can talk directly to Vertex through WebSockets, so it's in the browser. But if you look at the way these examples work, so like if we look at our portfolio app here, app. Actually, we'll so our dashboard, we create our HTTP server, right? And this is what it takes for us to create an HTTP server. And then we also have an event bus, right? So we can talk to the event bus. And portfolio implementation. And we send JSON messages back and forth. In fact, you notice when we send our audit system, for instance, we get a JSON object as a result. And we're doing some RX stuff in here. So we're doing a select statement, and we're getting back a result of JSON objects from our database, right? And then we close our connection at the end, right? So it doesn't look like traditional JDBC. And Vertex offloads JDBC and has its own JDBC library so that you can execute this asynchronously. Exactly. JDBC is still synchronous. Postgres is working on some asynchronous stuff, right? But yes, today, in fact, that's why often you would send a message over to your event loop, to your event message bus, right? You'd pull that off, and you have an asynchronous wrapper to make your JDBC call, and then throw your result back. So what that means is you don't have to block. So like in a servlet, traditional servlet, you would block while you're going and getting that data. Now we don't have to block. We can stay responsive, but you're absolutely correct. JDBC itself is still synchronous. Right?
Looking forward to the async.
Yeah, at some point. Yeah. We'll get there eventually, right?
Jeremy,
yeah.
Vertex has a built-in async driver. Did you know that?
Yes, Vertex does have a built-in async driver.
For Postgres.
Yes, for Postgres. And then, I did not say that.
Okay.
But thank you.
So you just
So yeah.
put it on the message bus, and then it'll
Yeah.
just push it right into the database.
Yep.
Sorry,
Yeah.
is it that we can write without reactive programming, reactive systems with like two-way communication between like one service listens to the root queue and then the other one listens to the other one and they just go back and forth?
Yeah, so the question was, without writing reactive programming, can we talk asynchronously from service to service? So yes, there's a couple. Yes. So you can do a number of different things. You can send a handler over, so that you can execute the handler as part of a Lambda, right? You can also, when the message comes back, everything inside of Vertex, let me see if I have this code sitting up here. Everything inside of here is going to execute asynchronously, right? So even when we're doing simple HTTP stuff, general HTTP stuff. So like an example, here, this is a good example right here. So if we look at like what we're doing here, we're actually calling a URL, right? So we're going to call a URL, get our result back. This is the context that we're executing inside of the thread, right? And we're going to get if we get our response back, we send our response. Otherwise, our callback comes back, and we're going to say if our callback succeeded, we're going to do that, right? And if you notice, this is itself a Lambda, right? So our callback's going to come back in. We're going to execute that code when that comes back. And so this is very reactive programming in the style of first we define something useful to do with our result set, right? And then we're not defining an observable here, but then we're going to execute that code. And then when that returns, we're going to deal with the results. In the meantime, we'll do other stuff, right? In the meantime, the backend Vertex will go on to the next request. So yes. In fact, if you go back to the Netflix example, when he talked about how they would do that is to build a single page application or any kind of modern API, right? We're making lots and lots of calls in the back end. And if we go into a microservice, if we refactor an application of microservices, let's say we're all working on one big application, right? Today, one big monolithic application. We're building, redhat.com. Redhat.com isn't really all that big anyway. Let's say we're all building one big application. We're going to refactor that and split it off into microservices. And you guys are going to be in charge of the login, right? So you guys are going to write the login microservices. And you guys are going to write the welcome homepage, service, right? And you guys are going to build out, our subscriptions so I can see which Red Hat products I'm subscribed to. So you guys come in and they're going to build the UI. They have to call your service to log in. They're going to have to call the subscription service. They're going to have to call some recommended articles, right? We know that you're using these products. We have some security updates. We're going to have to call that service. Well, if you do that, blocking, right? You're calling lots and lots of different services. The ability is to wrap that inside of a reactive call means I'll fire off all those calls at once, and they'll start coming back, right? And I can start dealing with them as they come back. And then if one doesn't come back, or if I get an on error, right, then I know, like, okay, I can take some kind of action. I can plan for some kind of action, right? So maybe I can't show you all of your subscriptions right now. I display a default message. Right. Yeah, so it's got this callback, and so it's gonna, when the callback hits the thread again, the event loop, it'll come back in. All right, so to sum up, Vertex, it's reactive from end to end, right? It was started that way. It was built from the ground up on the concept of non-blocking, an event loop. The message bus is built right in, as you might expect from a guy that wrote, wrote a JMS engine. RxJava is also built in, so if you're familiar with RxJava syntax, you can do RxJava right inside of Vertex. In fact, I think the example we had here, you can get back a single is just an observable that does one thing. So you can get back a single result, right? So you can use Rx syntax directly. It's also polyglot, and the guys have spent a lot of time trying to, obviously you can write different languages on the JVM, but they've spent a lot of time making APIs that feel like a different language. So if you're using Groovy, it feels like Groovy. If you're using Ruby, it feels like Ruby. Right? It's not kind of grafted on. All right, so Spring's Project Reactor. I'm sure not, is there anybody who hasn't used the Spring framework in the room? What? Never used, okay, very cool. So we have one guy that hasn't used Spring, so I won't go into too much Spring details, right? But Spring Reactor is a new project for Spring Reactor to be a reactive project. And the Spring guys, sort of their sweet spot, right? They write really nice APIs, right? They write APIs over other people's stuff. And so they began to write, they set out to write easier APIs on top of some of the observable reactive programming, right? So I mentioned there's quite a learning curve. They were going to make it easier. So they changed the names. Instead of observable, they have Flux. Sorry, they have Flux and a mono is a single. But by the time they got done, they ended up with pretty much the same API. So it's not very different. You just kind of have a different syntax, right, for what you're using. They're also participating in reactive stream specification. And what they've done with their reactive project is sort of bake it into Spring under the covers. It's not really exposed quite as much for end users to use, or end users like us, like who are writing applications and using their technology, but it's inside of Spring. So they've added it inside of Spring MVC to start with, and it's called Web Flux. And essentially what it does is it gives you the ability to write kind of Spring endpoints like you normally would, but to get back a mono, right, or to get back their observable. Get back their version of observable. Where is their stuff here? So very similar to if you've done Spring stuff before, right? It's a greeting handler, and this handler gets mono, right, which is their single. So this is an observable or a flux that's only going to send one response back. Other than that, this looks pretty similar to a regular Spring applications. And that's kind of the intention of the Spring guys, was basically to hide this, to put it under the covers and let you use it inside your applications. But there's one of the drawbacks, for instance, if you're making database calls, the JDBC is not synchronous, right? So you're still going to block while you're making your database call, right? Although if you're not doing, there are certain use cases where it would fit, right? But not if you're making blocking database calls. All right, so to sum up, Spring Reactor, Flux and mono instead of observable or singles. It's Web Flux. It's built in underneath the covers. You can use it inside of the web. And then they're also participating inside of the Reactive Streams initiative. And then the notion behind Reactive Streams is to make these sort of things work together, right? Because we know we're going to be writing streaming applications. We know we're going to be writing services using these different technologies. The idea is that we're building some tooling under the covers to make it easier for them to interoperate with one another. All right, so I promised a bunch of links. There's a lot of good material out there. There's a lot of PDF books are available for download. This Designing Reactive Systems is an Akka book. Another Akka book that I read that I didn't include here. A couple of different webinars that are pretty useful to get started. Like I said, I'll put these up on SlideShare and we can make them available so you can grab these. These links are all good, right, so you can click on them. Vertex has two really excellent books that are available as PDFs. A Gentle Guide to Asynchronous Programming with Eclipse Vertex. And Building Reactive Microservices in Java. Those are both available from vertex.io or from the Red Hat developers website. Tutorials for Vertex are also really excellent. This one that I was looking at here is this one. The introduction to Vertex is also really nice, walks you through building some RESTful APIs, sets up a number of different things you'd use. Some good presentations too. RX Java, this book I would highly recommend. This is by Ben Christensen, who's one of the guys that worked at Netflix. And his presentations, he has two go-to presentations that he does a really good job explaining, the reasoning behind RX Java and behind adopting RX as a technology at Netflix. And then there's some good tutorials. This guy is the other author of or was the other person at Netflix and an original author, I believe, of RX Java. And he's got a nice series of tutorials here. And then Spring, this blog notes there's a number of parts in this series, and then I think this was the keynote presentation they gave at their conference last year. It kind of walks through using WebFlux and creating a WebFlux application. All right, so next up, so now that you've heard about reactive programming, you'll see some here as part of the shootout. We're going to do the Roar shootout. So Ken Finnegan will be up first. He's the lead for Wildfly Swarm, author of the forthcoming book on Wildfly Swarm and microservices, and author of two books previously. Brian Ashburn will be showing you Spring Boot. They'll show you the same application too, right? So you'll see the same application written these ways. Lance Ball, who's one of our core committer on Node.js, will show off Node.js. And then Devin Phillips, who is with our Open Innovation Labs, one of our consultants, will show off Eclipse Vertex. And he's used Eclipse Vertex a lot more than I have. He's used it for quite some time. So you get a good look at each of these. And hopefully you'll go home and start hacking a little bit on this. The tutorials for a number of these projects are really good, and especially with RxJava, even though it's a little confusing at first, once you really get your hands with it and kind of start working with it, it does become pretty natural, and it seems like a really nice API and a way to program. All right, well, thank you very much. I guess we'll have a couple of minutes. I fell a couple minutes early. Any questions from anybody?
Do you have a preference, and can you tell which of those frameworks that you covered or you are have drawbacks of it? They all have great features.
The question was about the drawbacks to some of the systems. Okay, yeah, so that's a good question, right? So they do all have things that I would recommend them. Drawbacks, the biggest drawback to using RxJava is the learning curve, right? It definitely is difficult to wrap your head around initially, especially at first. You spend a lot of time looking at those marbles, right? Then once you kind of get it, then you're like, okay, that makes sense. The drawback to any of these systems, by the way, is that reactive programming is a context switch, right? We're used to writing blocking code. We're used to controlling the order of execution. Vertex, to me, seems the most natural because I mentioned my first job was writing JavaScript, and the notion of callbacks to me is very normal. And you can write Vertex without using RxJava and just using callbacks to handle things. And so that's very comfortable for me. I also like the way Vertex Web is really nice and easy to use, the way Vertex Web works. So it's really easy to be productive and fast on that. And I also like the way that you can push things off to the message bus, and do message-driven development. I find that kind of notion, I find it very comfortable, very easy to deal with, right?
And so about 27 years ago when I was learning Windows programming and using all those WM_page messages, and I couldn't possibly block the execution because the window freeze. Is this new thing exactly the same?
So, was this like when your window would freeze and block?
Yeah, well, because it was also message loop.
Yes, it's an event loop. I never did any Windows programming, so I can't speak directly to doing Windows stuff. So you can set like timeouts too, like on calls and stuff. So part of the notion behind reactive in general is we're going to get errors sometimes, right? And deal with it. Make sure you're staying responsive. Because the core, the Reactive Manifesto, right? Responsive, resilient, message-driven, elastic. We're baking in the notion that errors happen, right? The network's fallible. Data changes, right? All this stuff's fallible. So you're going to handle errors quicker, more quickly, typically speaking. But reactive is a way to is a lot to get your head around initially. Drawback to Akka is, I really do like Akka. There's a lot of clever stuff inside of there. But it's a system. you basically build things in that system. But to a certain extent, all frameworks kind of have that, right? When you bite into a framework, you kind of have to buy into that framework.
Language preferences, like I've seen Vertex used to have significant support for Scala that subsided over the years.
So the Akka guys also have huge. These are the guys that wrote Scala, right? So if you like Scala, it's very natural. In fact, my colleague Brian Ashburn, who's going to show off Spring Boot, it was explaining he's a big Scala fan, right? So you can grill him on Scala questions. But he was explaining how the Scala type system does a lot of things, and I think it's very similar to the way they pass classes around. You just get your class, and when you see a certain type of class, then you just know what you do. You don't even necessarily have to get values out of it. So the only drawback I would say for Akka is, you use that system, you have to bind to that system in the notion of the actor model. If you don't like that, you're probably not going to like it too much. But there's a lot that's clever in there. Vertex, the drawback, reactive in general is a context switch. It's a little bit different. It's not a servlet programming model, right, if you're using the web framework. It's not like guaranteed delivery messaging, right? Because messages can drop. If they drop, right? So fire another one off. But that also goes back into the notion of, that you're responsible for dealing with your own messaging. So in Scala system, we know the network can be fallible, right? Maybe we send a message, maybe it doesn't come back, or maybe we don't get a response. We should deal with that in our programming, right? In our code. RxJava is the learning curve. Spring Boot, I guess they haven't really baked. There's not a lot there yet, I don't think. It's kind of hidden under the covers, which in one sense is good, right? Because you don't have to notice that you're using it too much. On the other hand, it's really not reactive end to end. Thanks. Yeah. RxJS. So, and this one example, that the marbles here. Did I close the marbles tab? So you do have languages. With the Rx world, you've got languages for just about anything, right? RxJS, the Rx marbles. This is all written in JavaScript, so you can grab the JavaScript to this and play around with this. And then JavaScript's very nature, too, works a lot. Like Node.js, right? It's a single-threaded event loop, right? You use callbacks in JavaScript. That's what I was saying. I've always done a lot of JavaScript, so the notion of doing callbacks and having lambdas, in the Java world is natural to me, and I like that kind of notion of programming. Oh, React. Oh, good question. The question was, RxJS and React, the JavaScript framework, related? So React is not really reactive. Even though it's named that. So no, they're not, they're not related. There's also another term, you'll hear a lot of guys toss around the term functional reactive programming. So functional reactive programming really isn't what we're talking about in reactive today, although people do use the term interchangeably a lot. Functional reactive programming, and it's got Connell Elliott, functional reactive programming is an older concept, and it deals with data that changes over time. So we're talking really here about streams of data, but not watching data that changes. And functional reactive programming is really about watching data that changes and reacting to the changes in the data. So functional reactive programming and React, which React is a great JavaScript library. I like using React quite a bit, right? But yeah, it's not really reactive. I'm sorry? Angular is, I really have not used Angular 2, so sorry. Yeah. So it could be. I don't know. Any other questions? All right, you guys ready for a shootout? See how some of this stuff actually works? All right, thanks.